Next up, we're going to be looking at, if you look at the slope and lines handout, we just did 8 and 9, so now we're looking at question 10. A big question, takes up a lot of space. It's going to require me to use my ruler here, do some good graphing. So if you're looking at, whoa, went away from me there. If I look at question 10, it tells me on this graph, do the following steps. I got a whole bunch of steps here, A, B, C, D, and E. And it tells me since no scale is given on the graph, I see there are no numbers here telling me how much each square is worth, I must label it myself. Let me start with that. I'm going to say, all right, this, let me pick a color here that will be able to show up on the black here. This will be a good, nah, yellow isn't great. Orange, oh, tangerine. Oh, it makes me hungry. Okay, so this is my origin here. I'm going to put a little 0 here just so I know exactly where the origin is. That's 0 on the x, 0 on the y. And right here, this first notch, I'm going to use a scale of 1 for the x-axis, because then that makes it easier for me to keep track, right? I can count 1, 2, 3. And the scale here for the y-axis, each of these notches is worth 1. Now, I could put more numbers in here if I want to, just to make it easier to keep track, right? I could say to myself, that's 2, 3, 4, 5. Maybe I'll put a 5 in there just to know exactly where I am. And I'll do the same thing along the x-axis, right? I'm going to put a little 5 in here. 1, 2, 3, 4, 5. Okay. Now, the first question here asks me to graph the line that has a slope of negative 0.5. And that goes through the point 5 and 1. So I can say to myself, well, I know that this point here is 5 and 1 right there. That's a point. And so I know I have to have a line that goes through that point and has a slope of minus 0.5. Now, a slope of minus 0.5, another way you can think of that is, the way I like to think of it, as instead of minus 0.5, it's like minus 1/2, right? Minus 0.5 and minus 1/2 are the same thing. This here, this slope is the same as this slope. The reason why I write it like that is because if I'm thinking here to graph, I want to use this idea of rise over run. Right, I've got a rise of minus 1 and a run of 2. And a rise of minus 1, that's like going down by 1. I got a rise of minus 1, so I'm going down by 1. And I've got a run, positive 2, which means going to the right by 2. So I rise by minus 1, and I run over 2. I rise by minus 1, I run over 2. Or I could also think of it as, if I'm starting from here, right? Like if instead of writing it as minus 1 over 2, negative 0.5 I could also think of as, let me erase this bit here, I could think of it as 1 over negative 2. Because 1 over negative 2 is the same number as negative 1 over 2. But if I think of it as 1 over negative 2, then I'm saying a rise of 1 and a run of negative 2. A rise of 1 and a run of negative 2. You see, it's lining up with the other lines. It gives me the same slope. It's because it's the same number. Rise of 1, run of negative 2. Now, you don't have to have all these dots on your graph in order to draw a good ruler line through them. But it's a good idea to do it because it makes your ruler line more exact later on down the graph, right? If you only have 2 points, then you might not line up your ruler perfectly. And if you have all these lines here, you're going to do a much better job. So now that I've got all these points here, let me draw a nice line that goes through all of them. And I got my line. Right? It goes through 5 and 1, and it's got a slope of minus 0.5. Now, the next question, B, asks me to graph the line corresponding to the equation y equals 2x plus 6. And it tells me you may want to make a table of values. Now, I can make a table of values here. I can say to myself, let me make a little table here, my crude paintbrush, and this is much harder than I think it probably looks. So I'm going to put x on the left and y on the right. And then I can make some cross lines here to make my little table of values. And then I'm going to put in some numbers here. I'm going to type them in because it's easier. So let me just pick some numbers that I want to pick. I like 0 is a great one to have in there. And then I could pick, I don't know, 1, right? And then let's say 2. And just to keep things exciting, I'm going to put a number 3 in there. Bet you didn't see that one coming. Now, I've got x values here in my column, 0, 1, 2, and 3. And I've got my equation as y equals 2x plus 6. If I want to figure out what y's go with these x's, then let me just plug each of these x's into my equation, right? If y equals 2x plus 6, let me think of that like this. Y equals 2x plus 6. I'm replacing each of these x's here with the x's in the table of values. Like if I replace this x with a 0, then I do the math here. Y equals 2 times 0 plus 6, which is y equals, well, what's 2 times 0? That's 0. So y equals 0 plus 6, and I know what 0 plus 6 is, and that's just plain old 6. So I figured out when I plug 0 into the x spot here, y equals 2x plus 6, when I turn that x into a 0, y ends up being 6. That means my answer here is 6. That's how a table of values work. Right? Now if I were to do that again, and instead of using 0 here, I know that I've got to add, I've got to use x is 1. Let me put that in there. Instead of 0, I'm going to put x is 1. And if x is 1, then here I have what's 2 times 1? That's going to be 2. And then 2 plus 6 is going to give me 8. Right? And that's how making a table of values works. Right? I think you see how it works now. I'm going to fill in the rest of these spots here in a way that I bet a lot of you can figure out how I'm getting these numbers. You notice I'm just making them go up by 2 each time, because if I know that my slope in my equation is 2, I can cheat and just say, well, I'm going up by 1 on the x's. That means I got to go up 2 on the y's. In any case, now that I got these numbers here, each of these is a point I can put on my graph. Right? If I have 0 and 6, let me put 0 and 6. That's 1 point on my graph. 1 and 8, I got 1 and then 8 right up here. And then 2 and 10, that's right there, right? And 3 and 12 would be up here, but it's off my graph, so I'll put it there. Now, some of you might have seen a shortcut here. You saw, well, I know that this equation here has a number here for the slope and a number there for the y-intercept. And if the y-intercept here is 6, then right away I can know, oh, well, that means that 1 point on the line has to be this one right here, which we ended up getting. X is 0, y is 6. That's what that number means. That's a point on your line. And then I can get other points by just using this slope here and counting rise over run, right? 2 is like the fraction 2 over 1. That's a rise of 2 and a run of 1. So rise of 2, run of 1. Rise of 2, run of 1. I'd get the same points I got when I did the table of values. So there's more than one way to get to this answer, but once you got enough points there to make a good straight line, that's what you're going to do. You're going to draw it across your graph, and you've got to make sure it goes all the way to the edge of your graph, just like that.